Welcome to this video on the topic of programming. In this video we're going to have a look at how we can use a flowchart to understand the behavior of a program. So observe over here, we've got a flowchart that depicts the behavior of a program called a canting program. And basically what this program does is the user gives it a number and the program is going to start from 0 and incrementally count upwards until it reaches the number that the user's given it. At every given step, the program is going to output the number in which it's counted up to. Now, if we wanted to see this run in actual code, what we've got here is a Python implementation. So watch how it's going to run. To click run, it'll ask me how high shall I count, and let's say count to 5. And what this is going to do is it's going to go, the count is 0, the count is 1, the count is 2, the count is 3, all the way up to 5. So this is a really basic program here. Now, looking at the behavior of this flowchart, what we want to do is we want to increase our tool set such that we can actually observe the behavior and simulate the paper on pen and paper. Now, first thing I'm going to go and do to do this is I'm going to write out all of my variables that I'm going to be working with. So what we can see is we've got a variable limit here. So this is the variable that's going to hold the information or the number that the user gives it. And then we've got this variable count, and this is going to be the variable that counts up to. So the way in which I represent those is I draw like a little bucket. So I'm going to write limit. And above the limit, I'm going to draw a bucket. And then I'm going to write count. And I'll draw a bucket like that. And what this represents is that limit and count are variables, and they're going to hold information. Now, the next step in drawing one of these data flow diagrams is we have to label all of the steps in the code. So the first part I'm going to do is 1, and this 1 represents the starting block. I'm going to go 2, where the user inputs the information. 3, where we initialize the variable count. 4, where we have a look at the decision of whether count is less than or equal to limit. 5, when we're looking at printing the information to the screen. 6, when we set the program counter or we increment the counter in the program. And we'll just leave it at that for now. Now, next step is I'm going to draw like a little table. So start off, and we'll go this color here. I'm going to write step. Then I'm going to write my two variables we're working with. So we've got limit and we've got count. And finally, I'm just going to write console because this will be the output of the program. It allows us to observe what the program's doing at any given time. Now, next step is I'm going to write the numbers out. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8. And what these numbers here represent are the place in which, or the steps in which the code is flowing downwards. So I'm not sure how many numbers we're going to use just yet, but we'll stop it at 8, and if we need more, we'll keep counting upwards. Now, next step is under limit and count, these represent our variables here and here, also initialized here and here. So what we're going to do is at step 1, we're at this part of the program here. And the values within limit and count, there's nothing in there, so I'm just going to draw a dash, like so. Then the console is also nothing. So we can put a dash there, or we can just leave it as nothing. Now, next one is we've got step 2. So we've moved into this part where we're getting the information from the user, or we're asking the user to input a number to count upwards to. In this case, over in the test program we did here, we inputted the number 5. So I'm just going to use 5 as the test data. It could be 6, it could be 7, it could be whatever you want it to be. And the count at this stage is still nothing, and similar for the console. Now, next part is we go set. So set count to 0. So this is where count over here becomes 0, and limit is still equal to 5. In the console, that's going to be nothing. Now, next step. We're at the part where we have to decide, is count less than or equal to limit? So we look at this and we go, is the count here, is that less than 5? And in which case it is. So we're going to go 5 and 0 because they're unchanged, and then we're going to say yes it is. So we move down, so we go from this block of code here downwards to this block here. Now it says print. The count is count. So value of limit is unchanged, value of count is unchanged, but now we're printing to the console the count is, and then we'll go 0, like so. Moving downwards, we go to set count to count equals count plus 1. So now our count was 0, so we're going to put plus 1 in it, so it becomes 1, and our limit stays as 5. Now we follow the arrow back up to the decision making process here, and it says count is count less than or equal to limit. In our case, count is 1, limit's 5, so yes, it's less. So we go down into this yes block here, and it's going to ask us again to print. So 5, 1, print the count is, and in our case it's 1. So we're going to put 1 down. Then downwards to next step, 6. Set count to count plus 1. So we're at 1, now we're going to go to 2, and limit's unchanged. Now, I've run out of numbers, so I'm going to increase these just by a little bit. Should be enough for now. Alright, so we've just incremented our variable count. We're going to follow the arrow back up, and we ask ourselves the decision again, is count less than or equal to limit? In our case, it's 2 is still less than 5, so it's yes. So we're going to repeat what we've just been doing. So 5, then 2. Then we're going to print it to the screen. And we're just going to keep following this process around and around until we finally get to the condition where count is greater than limit. Alright, now we've just gone to the condition where we've incremented the variable count, and we've gone up to the decision making tree here, and this block it says is count less than or equal to limit. So have a look, count is now 6 and our limit is 5. So what's going to be triggered is, rather than going down this yes path, we're going to go down the no path, and the no path is, well, the program terminates. So once we reach that part here, then we are done. So let's just write finished to symbolize that the program's finished. So what this has been able to do is this little diagram here, or this table here, allows us to track firstly the variables or the contents inside the variables, and secondly it allows us to track the behavior of the program. So what we can see is there's roughly 1 to 17 steps that are involved when the user inputs a value of 5 here. So this is a great little tool for allowing us to firstly understand the behavior of a program, and secondly to observe the behavior on pen and pencil. So if we run it again, what you can see is the behavior of the program. It matches up 1 for 1. Let's go. Matches up 1 for 1 with what we can see here and here. So just a really nice tool to work with. In the next video, we'll have a look at a more complicated version